First of all, I would like to welcome all the participants of the 9th International AI Journey Conference. I'm going to briefly talk about the focus areas of our work. We have 3 focus areas. First one is the coordination of the activities of the research centers. First of all, we're talking about the fact that you have to select the scientific centers of the third wave that Mr. Chernyshenko talked about, and to respond to the issues raised by the centers of the first and second wave. The second focus area is coordination of the efforts in AI. It can span across different fields and areas, but first we have to create a common program related to AI. Second, we need to organize the second foresight that we have talked about. We're talking about standardizing AI applications, talent training, so quite a lot of tasks in this focus area. The third is awareness raising of the scientific efforts and building horizontal ties and peer-based ties with the international scientific community. I see the Sapphire agenda as follows. Our task to make sure that AI science in Russia becomes understandable, result-oriented, effective, and attractive to everyone. It is ambitious, but you cannot be a scientist without ambition. We accept that ambition, and we're going to work on that, and I believe that everything will work out. I don't think we have to focus on the plans for a long time. In 1 year, AI Journey will mark its 10th anniversary, and we will discuss the results that we will be able to deliver. We're going to have pitch sessions of the heads of the research centers of the first wave. We have experts in the first row. They will be able to assess the results of and the deliverables of the first wave research centers, and you will be able to understand what our scientists were doing all this time. Right, so we have a very strict time frame. Please do not spend more than 5 minutes for your presentation. That is going to be followed by a Q&A session. I would first like to introduce the experts sitting in the first row that will assess the work of the research centers. Dmitry Chernyshenko, Deputy Prime Minister of the Government of the Russian Federation. Maxim Kolesnikov, First Deputy Minister for the Economic Development of Russia. Andrei Belevtsev, Senior Vice President, the Head of the Technology Development Block of Sberbank. And Rutun Avetisyan, the Director of the Institute of the System Programming of Russian Academy of Science. And Academician of the Russian Academy of Science. Okay, so let's get cracking. And our first speaker is Alexander Bukhanovsky, the head of the Research Center Strong AI in Industry of ITMO University.
Благодарю.
Thank you all. Are we going to, you're going to stay with me on the stage? Yeah, great. Right. The Center for AGI for the Manufacturing from St. Petersburg. ITMO University has a great experience in working in digital technologies and heavy machinery and engineering, and this is why we focused on creating the solutions for the experts from manufacturing and from the creative area. Our frontiers are about automatic machine learning, generative design, creation of digital twins with AI, and putting it all in the fundamental models. But since these focus area is relevant for the scientists and is supported by the communities. A couple of our papers created some IP-protected patents. We've earned 370 million rubles by sharing it with our industrial partners. We have more than 1,000 people who were retrained based on our platform. So we share our knowledge. We do not keep it a secret. And that goes from the heads of the regional universities to the high-ranking officers from the Ministry of Defense. And we have the largest ecosystem of open code, maybe the largest one in Russia, and almost 2,000 stars from 41 countries in the world is what we receive. There is a cancel culture that we're experiencing right now. However, the quality of our work supports the fact that we are pretty good. Now, this is science, but we work for the real sector of the economy. We work from various enterprises, from the spaceship construction companies to the fish conservation companies, the fish canning companies. But we also have our platform, our own platform. We have a special test polygon to a test field to test our systems. That helps to drastically increase the speed of our development, and this is where we create our final solutions. The systems for assistant decision makers, for the mining fields, optimizing the oil fields and the well constructions, because we work a lot with oil and gas companies. But the major effects, the major qualities of these technologies can be properly leveraged when we create them based on the AI technologies like generative AI and LLMs. And we have created a proto-LLM, an open framework that helps to prototype these models very quickly and build them based on the multi-agent technologies and to retrain them based on the industry. Akela AI. It is a very sharp system that helps to resolve strategical tasks like Tatneft company, an oil and gas company. It was delivered with the close cooperation with this company. We've gathered many experts, with different experts like drilling experts, safety experts, and those who know the history of the company. Because we wanted to understand whether the company used such similar solutions and how they were used. But there were no experts, human experts. It was a multi-agent system. Many smart agents are working under the hood of the system. There's a huge fundamental model that underpins their work, and they can work together to consolidate their solution. This is an open source architecture. It can be scaled from companies to industries, and that means that a professional AGI, that is a step towards a professional AGI, and for the nearest years, this is our goal. Thank you. Thank you very much, Alexander. Okay, experts, your first question. Maybe I will try. Could you please tell me, you put a very ambitious task, professional AGI. What would be the metrics? How are you going to measure our progress towards AGI? A professional AGI cannot be measured properly currently because, because you put two very complicated challenges for yourself: professional and strong general artificial intelligence. Well, AGI, professional AGI is a bit kind of might be easier than the general AGI because working in manufacturing and industry is, it was easier for us because there are many standards and databases, the hardware and software, and the experience of creating real projects. So for us, the criteria of the efficiency is that the system can do the things that the best experts in the field can do, but experts can prove that it is working in the right manner. We, as we worked with the industrial companies, we understood that for a lot of tasks, a model should know these state standards called GOSTs. There are still problems with GOSTs because they are not fully digitized. Not all of them are digitized. And any international pre-train, pre-train model, they do not know the GOSTs. And so this is where we see the problems. Yeah, by the way, these are the risks that I was talking about. Yes, absolutely, Mr. Chernyshenko, because I do not know what model did you take. There was a pre-train. There were no Russian GOSTs in the international pre-train models. So that's the first thing. And second thing, we have problems with the digitization. Even for our own models, it is very hard to use them. How do you plan to address that?
This problem has already been solved, at least with the AIJ product that I showed, because it uses pre-trained models only for some basic functions like human communication. But then we fine-tune it in an automated way based on company documents, internal documents, regulations, reports that were collected earlier. As for the state standards, the problem is much more complex than it seems, because regulatory documentation, with regulatory documentation, there is often a lot of discrepancies between the documents, and models starts getting confused. So now, as part of our efforts together with the Ministry of Construction, we recognize this problem. So we want to first create the documentation, turn it from machine readable to machine understandable, and then use it inside our fine-tuned models. Thank you very much, dear experts. Do you have any other questions? Yes, I have a question for Alexander. Is it possible, in your opinion, to create an AGI that is industry-specific? That doesn't apply to all industries, but that is industry-specific. I think that it's not only possible, but is absolutely necessary. The AGI, if we're only basing on general tasks, it will be insufficient. So in order to have systemic development, we need to have the AGI model underpinning it. How do we know that it's indeed an AGI and that it is industry-specific? Well, on the one hand, it will be able to perform tasks that are specific to the industry, and it will be able to perform a variety of tasks, and we will need to ensure those mechanisms. Still not clear. Can you elaborate? So at which point will you be able to say, that's it, we have created an AGI for the oil industry? Three main attributes. First is that any company working in the industry is able to set a task and get a response that has relevance for the company, for the industry. Second attribute is that this response will be based not on the general context that you can get from a textbook that is 10 years old, but that is based on relevant up-to-date information. And third is that the response is obtained much faster than if you ask the question to qualified experts. A follow-up question: how do you verify the success of implementation of your solutions among industrial partners? Do you analyze any implementation metrics? So what is the verification mechanism? When we launch projects for the industrial partners, initially we do the preliminary feasibility analysis. So the industrial partner does the economics estimates, and then after the implementation, as the implementation is going, we do have an opportunity to verify certain metrics, not accuracy, but rather monetary ones. And then it's up to the partner, and it's up to them to decide what to verify and how. One more question from the experts. You said that you have no hallucinations and that you are on the cusp of creating an AGI. Did I understand you correctly? You decide whether it's an AGI or not based on external attributes, external criteria. What about the internal ones? How do you decide that based on the internal factors you are indeed transitioning to an AGI? I am specifically talking about a multi-agent system. Because if we take a model and we feed all kinds of internet data into it, it's not going to turn into an AGI. But multi-agent systems, they have collective behavior. Remember the Terminator film? They mentioned Skynet there. So it was a good premonition, I would say. The Nobel Prize was awarded to the physicists for the research in collective behavior. They figured out that these neurons taken together can display collective behavior, and it resulted into a new approach to analyzing the behavioral data and analyzing data. So you believe that this multi-agent system is a way towards creating an AGI? Yes, it is one of the ways to it. You mentioned designing. Did I understand you correctly? You have a design system? Yes. It's just that we worked with the developers and builders, and they have enormous problems with the actual estimates in resistance of materials. Do you have this problem? And do you solve it with AI? Two solutions to it. The RAD technology is about the connection of new estimation models. The second one is to avoid long calculations. So there are ways to create surrogate models. So once again, on the engineering and software suite, you can run these calculations. And if you have the machine understandable documents, we have more than 600 documents of this kind at the Ministry of Development that helps us solve the problem already. That's the project that is ongoing. Thank you, Alexander. Please take your seat. It's hard to be first. For all the other speakers, please make sure that you are within the allocated time frame and answer briefly, because otherwise we won't have enough time to hear from all of the institutions and universities. Our next speaker is Evgeny Burnaev, head of Skoltech Applied AI Center. Hello, colleagues. My name is Evgeny Burnaev. I am the head of Skoltech's Applied AI Center. A bit of background. The core of the team back in 2008 started developing AI technology and machine learning technology to optimize complex engineering products. And in 2010, we created a spin-off company because we realized this potential. The spin-off company continues to operate and to sell software across the globe. So we won the competition. It was also recognized by the Airbus experts as a technologically mature solution. We were developing these competences further. We grew as a team, and now the team, thanks to the experience that we gained in working with the industry, continues its innovations. We are creating fundamental technology and industrial solutions. The team is growing. We are cultivating new talent. We have received multiple awards. Here are some of the team members, and I personally have just received an award from the government, but that's not the most important thing. The most important thing is that my colleagues, my young colleagues, have been recognized. Nikita Gushin just yesterday received an award as an AI leader. We developed a number of AI-based frameworks to address a broad class of tasks that underpin the platform, but I'm going to go back to that in a minute. We have had publications, A-star publications. The number of such publications is growing year after year. So now the results. What we are doing for the government, based on the state budget, AI frameworks to improve the productivity of neural network models, for multimodal and 3D visualization models, a number of generative AI methods. These methods became a part of the platform that is used to support managerial decisions in sustainability based on data, data-driven decision-making. This is used to optimize oil and gas services, detect sources of pollution. This platform and these frameworks are something that we are transferring to the state as our customer, and we are ready to participate in the implementation of these results to tackle day-to-day solutions on the governmental level. Some of the platform components and frameworks are already used to implement a number of services. For example, the service to forecast the probability of forest fires, already used by the Emergency Situation Ministry. And also frameworks such as 3D processing of visual data used in medical applications. The framework for coupling of physical models and ML models is used to monitor technological processes, industrial processes, for example, in the production of pipes. These are the results that we got as part of our state budget project. And now what we do for companies, we are able to solve problems really fast. For example, we have developed a system to analyze climate-related risks and their impacts on the economy, on the economics of particular companies, so you can assess the risks in your specific portfolio and what are the dependencies on the climate scenario. We've also developed and implemented in the Barentsova and Karskaya seas a system to forecast the icing. We've also created an agent-based system for different tasks. When an operator is communicating with a financial institution customers, and it is important to respond fast and with relevant information, and some other frameworks. For example, with Gazprom Neft, we have a self-training model to assess the state of a deposit. Just 10 more seconds. The understanding of how the AI industry is developing, the understanding of what are the next challenges faced by industrial customers, gives us an opportunity to determine our steps forward towards AGI. We are developing engineering AI. In the second half of this Science Day, I'm going to have a presentation on precisely that. This is a system that uses Gen AI to extract industry-specific data from state standards and documentation, and there are agents solving doing specific jobs for engineering purposes. This is how we see the further development. Thank you. Thank you, Evgeny. Dear experts, just one or two questions, please. We're really short on time. I have one question. To what extent are you integrated into the actual operations of Rosatom as an operator of the Northern Sea route? And also, to what extent are your developments used there? So with Rosatom, we would like to be integrated to a bigger extent. We could benefit from your support, I think. The service itself in the Barentsova and Karskaya seas is being implemented for the benefit of Gazprom Neft. So the integration is really high for Gazprom Neft. Jenny, a question about self-training, self-generalization. How do you assess further development in terms of data that can be used for training? You can work with one company and one oil deposit, that's good and fine, but everyone is interested in generalization, and that's where the problem starts, I think. We've been applying it to not just one deposit, but multiple deposits. But speaking of the development track, the last one, the engineering AI, is about the development of these industry-specific needs and demands. This is a system that can self-generalize based on data, based on new data. We already have the methodology for how it should work. And for this concept of engineering AI, for generative design of sites, this is something that we have been working on. The generalization that you're talking about is something that is integrated into it. Thank you, Evgeny. Our next speaker, Denis Turdakov, Head of Research Center for Trusted AI of the Russian Academy of Sciences.
Добрый день. Ядром современного
Hello, machine learning is at the core of modern AI. Basically, this is an approach that helps you tackle tasks based on analogies. You are not describing the algorithm in full, you give it an example of problem solution, and you make sure the machine can learn to solve similar tasks in a similar way. This is a widespread approach, and we have heard about it at this conference, but this begs the question, what are the limitations? In which situations it certainly does not work, in which situations it does, and what is in between? To answer this fundamental question, we have created the Research Center for Trusted AI. This is an area that is of critical importance for the entire field of AI, and many recognize it. Indirectly, it is corroborated by the interest to our publications. This year, we have published 21 articles at A-star conferences, which is 20 more than the year before, and I was happy to see the voting results. Many people in the audience share my view in that it is indeed an important scientific area. I will give you an example to illustrate my points. Analogies for a human being and for a machine. Are they one and the same? The correct answer is no. You can come up with examples which for a human being will be analogous, but for the machine they will not. One of such examples is something that I'm wearing. It is on my sweatshirt. This is a picture, this is a pattern that makes me invisible for the YOLO system, often used in CCTV for recognition. So this pattern renders me invisible. Such examples are called adversarial attacks, and at our center we are developing methodologies and tools to repel such adversarial attacks and also other types of attacks that AI-based systems experience. The main product of our center is the platform for developing trusted intelligence systems. They are based on MLOps, meaning a solution that brings together various best practices in development and speeds up the development of AI-based systems. As opposed to the existing solutions, including open-source ones, we have added the ability to quickly integrate tools to work with attacks that are specific to artificial intelligence. There are 6 tools here on the slide. Out-of-the-box solutions, each one of them are alienable, so if a company has its own MLOps architecture, you can take one of the tools or all of them and integrate them into your own architecture. If you're just at the beginning of the journey, you can take the platform as is. Another area of focus for us is the security of software code in AI. Many use frameworks such as TensorFlow and PyTorch, but few look at the security issues associated with them. We have decided to tackle that problem, and we have implemented the methodologies in stacks. We identified vulnerabilities, corrected them, and based on that, we created trust flow and trust torch frameworks, and we committed more than 80 patches to the open source. As for industry-specific implementation, our tools are already integrated into commercial products such as Kaspersky Lab, and the trust torch framework has been tested by the state and is recommended for integration. TrustFlow is also pending implementation with our industrial partners. Thank you, Denise. Any questions? Yes, I have one. What is some of the fundamental research you need to create a trusted AI? In the field of AI, our field is very applied in nature. So there are applied solutions, but there is no theory that explains why this approach works so well and where it does not work. So we do need a fundamental theory. Alexander Gasnikov, mentioned here at the conference, is working on this problem as well. He has a team that this year published a very interesting result that shows that you can simultaneously achieve high security parameters and high processing speed with a number of solutions. So we do need this fundamental theory that would be underpinning our solutions, and then we would know for sure where this approach works and where it doesn't. Denise, people are asking where you can find such sweet shots. I have brought my own. Just give me the number. How many do you need? I can just share the pattern, so you can print it yourself. Thank you. Perhaps you can continue the conversation on the margins. Our next speaker is Ramil Kulev, head of AI University of Innopolis University.
Добрый день, коллеги.
Hello, colleagues. The main goal of Technopolicy Research Center is to create industry solution for various sectors of the economy, like oil and gas and chemistry and healthcare. Thanks to this center, we were able to achieve great disruptions in science as well as in industry-specific applications. We have more than 200 experts right now. I have 80 commercial projects for 2.4 billion rubles. Before the center, the creation of the center, we published 1 or 2 A-star publications. In 2024, we have 11 publications. Key results. The new optimization methods that help to drastically increase the speed of the model, and make them more interpretable and make them much more cost efficient. And the new educational programs were developed, including about the chemistry and information technology. But the key focus was to commercialize the ROSE. The platform for data analysis was created that helps to save up to 30% of the time and costs as the data analysis centers are being implemented. We use this platform in our projects. The key result is to create industry-specific platform solutions. They're here on the slide. I'm going to talk about them. As for the healthcare diagnostic, together with the Loganov Medical Center, we have analyzed the CT scans of the intestines and stomach, and there's a lot of data, and the scan reading takes more than 40 minutes, but now it's increased. The speed is improved. Also, the safety of the industrial sites were improved thanks to our solutions. But the main area is the AI for new materials. We got new publications in Nature about the 2D effects of the materials. We also took second place on the CT challenge. We were better than Carnegie University team, and we were second only to the Microsoft research team. And also the forecasting the structure of the materials task were resolved by us. For the oil-related chemistry was was the top priority for us. We can go from polymer creation to creating added value materials and increase the speed. Also the bitumen production improvement. We're also working with other partners in other industries. The key thing was to speeding up the processes of creating new products thanks to lower number of experiments, and this is a step towards the next stage. We're talking about this improving the science and the science in and R&D in the enterprises. We have Alexander Gasnikov as one of the heads of the teams, and I would like to say that this is the area where currently there are only the markets are only emerging around the world. I think that Russia has a great opportunity by creating the technologies and the solutions to not only import substitute something, but to become a real global tech leader. Thank you. Thank you very much, Ramil. Thank you very much for keeping it within the time frame. Any questions? Ramil, fantastic job. I remember how you launched. Great progress, really. You've gone a long way. This solution, can it be used as a standardized tool to support all scientists? Yes, Ms. Chernyshenko, we know about domain science, so we know how this accelerator can be used. Maybe can we next week to come up with the deadlines, and I will give the request to the Ministry of Science and Technology. One question: we have a big counterweight problem with small with the chemistry related chemistry, the light chemistry. And together with Nornickel, we're going to create this new project. And in Sibur, where they use catalyzers and they scale the catalyzers, do use these technologies. We were not able to reach them. Yep. Can I have a request? And could you this year reach out to them with your solutions? Thank you very much. Ramil has a lot of things to do. Roman Gorbachev is the director of the Center of Applicable AI Systems of Moscow Physical and Technical University. Hi everyone. In 2020, in MIPT, we've completed the first flagship project in AI together with SBIR. It was named the Deep Pavlov platform that gathered all the scientists on one platform, and that was an open source tool for developing applicable solutions. And when we prepared the program for the first wave, we formulated the following concept, that only by connecting to the world as a human, AI can create its own image of the world, that it would be near to the image that we and perception that we have as humans. This is an intellectual robotic agent that can understand the voice commands of the users and understand the connection to the physical world. We have created the prototype of this platform. The platform is for developing the dialogue assistance, robotics, and driverless vehicles. 20 plus 29 publications in Q1. Q1's publications. At the same time, the citation level is 5.2. We're being cited by Google, DeepMind, and organizations of this category. We've won 23 competitions on the globally, and have more than 100 million rubles of the revenue by commercializing the licenses. The key, our key solutions. We've developed a full framework that we call a digital test field. It is built to verify the structure of the robots. It has various libraries of the algorithms of AI to manage and control the robots. The digital test field also includes a catalog of various robots and a simulator to train robots based on the behavioral tasks from the user. The algorithms developed in the digital test field was used for anthropomorphic robots. We've created such a robot that, thanks to our test field, was trained on our storage facility, and this robot is now being used and tested in Vkusville, a grocery store storage facility. We are also using GigaChat technologies here. We have also developed a multi-camera sensor system and the controller for the driverless vehicles with the navigation and algorithmization mechanism. We have tested these technologies on a driverless shuttle that was going through the campus of our university, and we used the developments to work with one of our partners for the forklift driver without a driver. And the voice assistant was developed by us that can create the voice systems and dialogue systems that can talk with the humans, and creating a voice-empowered 3D avatars was one of the solutions. We work with Berla Robotics. We decreased the time for developing the platform that can do the steps. We have created a digital twin and the Fourier engine for the walking robot. We have created a parkour AI system that can recognize the barriers in front of the robot, that can make help robot make a decision on how to tackle that barrier. And together with the University of Kyiv, we have also partnered. We made a couple of workshops on IRIS conference for robotic football, and we have taken the second place on RoboCup. That's an international football championship among robots. Thank you very much, experts. Do you have any questions? Mr. Beletsov, I think the main question is that we talk about robots. How do you assess the outlook for the foundation model use in robotics? Well, we have two focus areas in our center. First of all, we're working on athletic intelligence when we teach the robot and train the robot to move intellectually. And here I can say that the simple task for a person is to take a bottle of water from a table. Cannot be done by a robot, by any robot in the world, and together we work with Alexei Ganachenko's team to develop new fundamental and foundational models, and we work with Alexander Panov from MIT Cognitive Lab. We understood that the classical LLMs for this task to plan the trajectory and to build the behavior of the robot are not suitable because they start to hallucinate, so we try to find new approaches. Roman, the request for you, we have a phygital strategy that was adopted in our country. There was this battle between the robots. So you have a more pacifist project with the robots playing football. Can you please work with these guys because they have their own lab? Could you work on the robotic football with them? And we will help you to organize an all-Russian competition. Yes, thank you very much. By the way, we have a standardized football player, robotic football player that can be scaled for these competitions. Thank you very much, Roman. A round of applause. And our sixth research center is head Alexei Masutin, the head of the Center for AI of the High School of Economics.
Уважаемый Дмитрий Николаевич, коллеги.
Mr. Chernyshenko, colleagues, it is my great pleasure to present our results. When we created the center based on the High School of Economics, we've selected the name Inter-Industry Research Center. And as we created the teams of our center, we adopted a regional development concept. In Nizhny Novgorod, in St. Petersburg, and Perm, and in Moscow, all the centers were working based on the program, so that we developed the competency not only in Moscow, but we have supported our regional campuses. We have 31 industrial projects for 7 industrial partners. That's our portfolio. We started with 3 large and mature, AI-wise mature companies like Sber, Yandex, and MTS, because Sber and telecom companies and IT were pretty good, have been pretty good in AI development and AI applications. As we continued, we worked with tourist companies and consumer chemistry companies and security companies. Our projects are supported by fundamental research. By the end of 2022, from the end of 2022, we have more than 80 A** publications and Q1 publications. Work with international partners from China and from Mohammed bin Zayed University at the High School of Economics. From 2022 is organized in a Fall into ML conference, World Conference. There we unite all the authors of A** publications, and every year we are growing by a factor of 2. And on the last conference, we had reports from more than 100 authors from Russia. If we talk about the fundamental technologies, so these are the 4 examples I would like to show you. They are related to the development of new approaches in generative AI and the adaptation of the current architectures to the specific domains. Bioinformatics, one example. The preventive healthcare is not possible without the analysis of pangenomic sequential research of our DNA, and our colleagues are using the deep learning techniques to bind various omics data to prevent arrhythmia and other neurodegenerative diseases like Alzheimer and Parkinson diseases. Then on the right-hand side, there's another example, new approaches to the generation. And now the current approach to the generation is getting the elements from the vector space, and you can use other examples. You remember AlphaGo. This is a set of tools based on the reinforcement learning techniques that helps the computers to know how to play very complicated games and be successful. We use this approach to generate proteins and presented the molecule as the Lego builder, and we asked the AI to build the molecule. The reward would be not the molecule, but the good features and properties of the molecule that the AI was able to construct. We had a big fundamental project with the Sber, together with IRE experts. We developed the tools based on the discrete domains. 18 months ago, there were no good papers on generation syntax with the diffusion models, but here we are speeding up the work based on the in multiple times based on large requests. In 2022, the international organization, unfortunately, that certified the languages left Russia. High School of Economics made a special certification based on that. More than 4,000 people got this certification. This is also checked by professional linguists. And to wrap up, 5 seconds, tourism. When we were asked to show us the case that we're proud of, we work with the Yandex, MTS, and Sber. But I think the most important thing is right now to make disruptions in the industry. And tourism is one of the industries when there is the very narrow margin, space and range. And this is how we help the tourism to help with our solutions. Thank you. Thank you very much, Alexei.
Dear experts, do you have any questions for Alexei? Alexei, can you please tell us, you're not the first speaker talking about AutoML, so what do you think? Will foundational models win? Will we have AutoML or not? Does it have any future? Good question. There are two schools of thought, two approaches to it, as we are training the artificial intelligence, adding modalities and tackling a more bigger variety of tasks. That's one thing, and the other approach is the orchestration. My colleagues and I, we believe that the orchestration is the way forward. If we are processing spreadsheet data or time sequences, usually they demand separate forecasting models. Large foundational models are not yet capable of it. Maybe this will change, but for now we favor orchestration in terms of interaction between models. Thank you. Let's give a round of applause to the research centers. Maxim, you wanted to add something? Yes, colleagues, thank you very much for this session. I'm very grateful to the research centers presenting the results of their more than 3-year work, more than 3-year research. The results are there, but that said, we have very ambitious goals set for us. We need to enjoy fundamental disruption in the next 2 years, and we are starting a new selection process of research centers based on the foresight session that we were working on for 6 months together with the Russian Academy of Sciences and industry experts, and we need truly disruptive fundamental research in algorithms and AI, AGI. A lot has been done, and still more is to be done. We're going to send you the draft documents for the selection process, and in February and March we will be looking forward to some very strong applications. Thank you very much. Mr. Chernyshchenko, anything from you? No? Okay, thank you very much. Hopefully that was interesting. Looking forward to your applications for the third wave.